This is SAT Test 2, calculator question number 34. College Board presents us with two statements about the hours that Doug and Laura worked. They spent a combined 250 hours, and Doug spent 40 hours more in the lab than Laura. When you have two statements about the same two quantities, that's typically systems of equations, and College Board asks you 6 systems of equations problems on each SAT, so it's worth making sure you can do these well. One of the problems will always be a word problem like this, or at least typically a word problem where you have to write the system yourself from the words of a problem. So let's write the system of equations. Doug and Laura spent a combined 250 hours in the tutoring lab. So that's the hours Doug spent plus the hours Laura spent equals 250. If I was using arbitrary letters, I would define them, but I'm not going to lose track of which of these is Doug and which is Laura. They also say Doug spent 40 more hours in the lab than Laura did. So Doug equals Laura, and since Doug is more, I have to add 40. We often put the 40 on the wrong side or put on the right side, but with a negative instead of a positive. So always check. If Doug spent 40 more hours in the lab than Laura, Doug would be bigger, and adding 40 to Laura does make that bigger. And the question is, how many hours did Laura spend in the lab? There are several ways of solving this. Since the important thing here is to review systems of equations, I'm going to look at several of our options. First of all, we have an equation already solved for Doug, so I can substitute that into the first equation, and Doug plus Laura equals 250. L plus 40 is Doug, plus Laura equals 250. If I subtract 40 from both sides, I get L plus L is 2L equals 250 minus 40 is 210, divide by 2, L equals 105. That's substitution. Another option is to put this in standard form, the same variables in the same order. So let's subtract L from both sides. Doug minus Laura is D minus L equals 40 is the only thing left on the right. Bring this equation down. D plus L equals 250. If I add these two equations, I'll get 2D equals 250 plus 40 is 290. Divide by 2. D equals 145. I could use the calculator, but in this case I won't. And since Doug equals Laura plus 40, 145 equals L plus 40. Subtract 40. 105 equals L. Same answer as I got before. As a third option, this is a calculator problem. I can solve this first equation for D. D equals 250 minus L. I'm going to subtract L from both sides of the first equation. Now I can go to Y equals, and for Y1, I'm going to enter X plus 40, and I'll make a note to myself that X in the calculator equals Laura's hours. And for Y2, on my TI-83 or TI-84, I'm going to enter 250 minus X, because again, X is Laura's hours. If I choose a graphing window where I can see all possible solutions for X, so their combined hours is 250, I'm going to say X max equals 250. I'm also going to do Y max equals 250, and I should be able to see the whole graph. So going to Y equals, I have X plus 40 and 250 minus X. In my window, X max 250, Y max 250, and I'm going to find the intersection, which is the second key, and then the trace key, second trace is calculate, and then I'm going to use option 5, which is either hit the key for 5 or scroll down and hit enter, and that's intersect. I'm looking for the intersection of the two graphs, and I'll just hit enter 3 times because the intersect function defaults to y1 for the first curve, y2 for the second curve, and it's not worth the time to scroll over to the point of intersection when I can just hit enter and the calculator will find it for me. And the point of intersection says x equals 105, y equals 145, and I said x is L, Laura's hours, so this is the answer they're looking for, and the y equals 145 is the same y value that I found previously. One more option. I erased too much, but I can rewrite it. I have d plus L is 250, and I already found d minus L equals 40, which says Doug spent 40 more hours in the lab than Laura. That was d equals L plus 40. I found this when I subtracted L from both sides of that equation. For a calculator problem with systems of equations, I can take the coefficients, 1d, 1l, 1d, negative 1l, and write this in matrix form. 1 times Doug's hours plus 1 times Laura's hours equals 250. 1 times Doug's hours minus 1 times Laura's hours equals 40. This only works if the variables are in the same order on the left-hand side of the equal sign for both equations, and the constants are on the right-hand side of the equal sign. So I enter this 2 by 3 matrix, and then I converted a system to matrix, and I'm going to use reduced row echelon form to convert this matrix to an equivalent matrix, which will have 1, 0, 0, 1 for the first 2 columns if there's exactly one solution. If there's no solutions or infinitely many solutions, I'll get a different display, but we'll worry about that another time. And then the calculator says 145, 105. Let's reverse what I did to go from here. I dropped the d and just put the d coefficient. So here I have 1. This becomes 1 times d is d, plus 0 times l. 1 times d plus 0 times l is just d, equals 145. 0 times d plus 1 times l is 0d plus 1l is just L equals 105, and we're looking for Laura's hours. This is my favorite method for the calculator section to solve a system of equations. Just allow the calculator to find the reduced row echelon form equivalent system, and since this system is equivalent under reduced row echelon form, the solution here is the same as the solution to the original equation, just much easier and not much room for arithmetic errors. Come back soon for my next math video. With math, there's always more.